morning, all. This is Praveen here, and warm welcome to everyone who are attending this webinar. And I hope you guys are safe and taking all the safety precaution measures and staying at home at your ease and still working. And we appreciate that spirit of working from home and continuing the business continuity chain. So yeah, what we are here, why we are here today is to see what is SOLIDWORKS Plastics and how we can detect the defects in the early stages of plastics manufacturing using SOLIDWORKS Plastics. So to give you a brief, this SOLIDWORKS Plastics is an analysis tool where we can use it right from the beginning of the product design to end of the mold manufacturing in several stages, where I just want to see whether my part is going to fill, whether the manufacturability of the part is fine, and are there any defects coming up, like sing marks, weld lines, and so on, which you must be familiar if you are a plastics designer or a mold designer, a product designer. So let us get on to this, and we will see what is what. Before that, we would like to just give you a brief on how to streamline the development process, where development process typically starts with a preliminary and project and concepts, and it goes on to electrical and mechanical design, where once the concepts is freezed, there are a lot of components, mechanical components, and then electrical wirings has to be done. So electrical and design and mechanical design happens. Then it goes to design validation. After design validation, if there is any changes required, it comes back to mechanical design or electrical design. So this goes on till you freeze that, and once every design is freezed, you will have to do the technical communication. We'll have to create a lot of manuals, marketing brochures, or sales catalogs, or work instructions, or how to assemble, disassemble, so many things. So this comes under technical communication, and then it goes to operations, manufacturing or production or whatsoever, and it goes to the market, end market. So in this, if the typical serial process, what happens if there is a change in the and at the end of the design, or if there is something happened in the prototyping, then the entire thing has to repeat again. So what SOLIDWORKS proposes is a process where all your integrated electrical and mechanical design, of course, integrated, it's not separate, it is integrated, and the design validation and the technical communication happens in a parallel way once the preliminary project and concepts are done, and then it goes to operation. That saves a lot of time if there are any iterations to be done to get the product out to the market or to the end stage life cycle. So everything happens inside a secured vault that is called project data management or product data management, that is PDM. So this is the proposal of SOLIDWORKS, where you can save up to 40% of your time, so that time always converts into money, so you can make the better decisions earlier using SOLIDWORKS solutions. So this is the proposal of SOLIDWORKS to streamline our development process. Let us now see where we fit in the design validation for today's topic, plastics. When the mechanical design is done, the concepts is done, and the mechanical design is done, it has to validate. In any design, we have to see the manufacturability of it, and there are a lot of other things, whether it can be manufactured. If yes, what is the material, and what would be the cost, what would be the maximum retail price or end selling price, and so on. So for this, there are various tools available in SOLIDWORKS, right from linear static analysis to high-end dynamic frequency, till the earthquake analysis, of course, seismic analysis, and so on, with different types called SOLIDWORKS simulation, professional, premium, and of course the CFD, the computational fluid dynamics for pumps and valves and electronic cooling, and so on. So all these comes under the umbrella of simulation tools, and plastics is one of that, where it is in this area where plastics products manufacturability has to be detected, and you can also detect the possible defects in the early stage of design using SolidWorks Plastics. Let us jump onto plastics and see what it is. So this is going to be agenda, introduction, and the plastics part designer, mold designer, cooling and warp, and summary. So we'll see one by one. These are the areas where SolidWorks Plastics comes into action, and there are some flavors also, of course, as many of you are aware of how the SolidWorks flavoring happens, or the bundling happens. It comes with the standard, professional, and premium features. So what we will see in the later stages of this presentation. Let us start. SolidWorks and plastics. You can see plastics everywhere and anywhere, right from consumer goods or aerospace, automotive, medical, electronics, every vertical, plastics are inevitable today. There is no product design without plastics today. There was an era where most of the conversions from metal to plastics happened in a very brisk time, and most of the parts are replaced with robust materials, plastics materials, and plastics are helpful in our daily life. We cannot imagine life without plastics, of course, except for the low LDP covers and other things which are banned. But otherwise, plastics is a very, very essential part of our life, wherein any industry or any consumer, any daily life. So what is essential here is to make the profitability and give the products to the consumer or the end user at a very competitive price, and at the same time we have to ensure the quality of the product and the life of the product. So for that, what happens here is the cost of change versus impact of change. In the early stages of your design process, part design or mold design process, if we find out the defects and if we correct it, it is what we are doing is locally on the CAD model, a 3D model, we are doing the changes and we are seeing the impact would be highest, but we are seeing that in the early stages of the design to manufacturing, so that costly errors are eliminated. What if the changes or the defects notified in the end stages, like in the prototype of the mold or in the production of the part? The entire process has to be redone, which the impact of the cost is very, very high, where it is going to be disastrous sometimes, where we have to throw the entire coral cavity, that is the mold, and we have to redo everything. So to balance this cost of change versus impact of change, what has to be done? Using SolidWorks Plastics simulation to avoid just one round of mold work can result in a positive ROI. That means there is return of investments. If we have predicted the problems in the early stages of the design, part design or mold design, that can result in a lot of cost savings. So of course, money also, the time is also saved, and time always implies to money. So here is the optimized cycle time of the part. For example, fill, hold, cooling. These are the cycles of the mold where the operation of the production of a plastics part, when the mold is loaded onto the injection molding machine. These are the stages it goes through typically. So there is a slight change in any of these will result in higher cycle time. So using SolidWorks Plastics, what are we going to achieve? So what is SolidWorks Plastics? Here, making a design suited for injection molding design. Predict and avoid injection mold defects at the early stages in the 3D CAD stage itself. Eliminate costly mold rework. Improve part quality with all the intuition and the intelligence built up in the software gives you, and decrease time to market. As we were discussing in the earlier slides, the 40% of the savings in the time, it gives a lot of room for us to be early in the market. There was a story on this where we on the field, when we used to meet customers, our customers who are into mold design and product design, we were discussing a couple of months back or a couple of years back, where one of our mold designer used to say, when there is a request for quote from any of the product manufacturers for mold, even before the quote is delivered from the local supplier, China used to send the mold itself. That was the competition in the market. And I don't want to take the advantage of the situation, but in this situation, it is it's a waking up call for all of us to make it local. We strengthen the local manufacturers and local suppliers, where we can build ourselves as stronger as the competition, or better than the competition, where we can deliver. We will be able to deliver the molds or the products in decreased time to market. So what is the SolidWorks Plastics workflow? Once I have a 3D model, it could be of any part, it could be an imported geometry as well. There is no restrictions as such. You have to use the SolidWorks model itself. It can be of any imported geometry, where we are going to mesh. Mesh is to discrete the part into different discrete quantities to facilitate the analysis. And we choose the material. We have the SolidWorks Plastics comes up with 5,000 plus materials, where you are seeing here. You can have the default database where you can sort by family, where the families are listed out like this, ABS and so many other combinations. And you can also sort by company, where you have the listing of all the major polymer granules or polymer material providers across the globe, where you can choose according to their specifications. And also you can create your own user defined database, where you have the material data from your material manufacturer, and you can load the same into the database, and you can save it as a material so that you can use at any point of time. And then we set the process parameters like mold temperature and the material temperature and the injection location and so on, and the boundary conditions like cooling and injection locations and all those things. And then run. After running, you can get the results. So this is the simple workflow what SolidWorks Plastics has implied. So when we see the example here, these are the examples. This is one simple example of a short, where there were changes, where the first iteration was filling the part only such distance, and then after several iterations, maybe 3 iterations virtually, it's not on the mold, but virtually doing the changes can result in avoiding the short, where you have taken probably 1 or 2 hours maximum to achieve this result, instead of spending days together when we find out there is a short once the mold is loaded onto the injection molding machine, which can imply a lot of time and cost across the organization. So as we were discussing, this is the material database, over 4,000 material and supplier specific. Let us see what is there in the plastics part designer. Plastic part designer can help me in predicting the filling process, where you have the options to select the gate location. Of course, the software also could provide you the gate location based on the volume and the geometry of the material, and user also has the the option to select his identified gate location, and you can predict shots once you start running the filling process. You can predict the shots. You can see the flow front and race tracking, and you can also see the ear traps, fiber direction, which is very much important in the products, which is aesthetically very important, and it is transparent and translucent, where fiber directions would define the transparency of your part which is going to be produced. And the weld lines are very common, where if you have a lot of features in your part, and there is a chance of 2 flow fronts meeting, and in the core and cavity you can see the weld lines, so that you can change your gates accordingly, and you can avoid those weld lines. and the sink marks, where sink marks would come, and how to avoid those sink marks can be easily done inside SolidWorks Plastics. So this is one simple example of filling, where you have identified the gate location here, and you can see the filling accordingly, flow and the fill time. And this is the example for short. Now once you are able to see the short, you can do the necessary changes in the gate location, or gate type of gate, or the injection pressure, and so on, and you can achieve the full flow, and you can avoid shorts. Weld lines, as we were discussing, where there are flow fronts meeting. Now the flow is unidirectional from the gate location, and it flows across in the core and cavity, and there is a possibility of your flow fronts meet at one point of time, where it diverges from the insert here and meets here. So you will get the weld lines accordingly there. So how we are going to overcome it is, you can change the gate location accordingly, so that you can maximum avoid the flow fronts meeting, and you can also design the gate as such the flow fronts are meeting at the edges of the part, so that weld lines are not visible. Ear traps, due to the chemical properties of polymers, sometimes ear traps happens at the critical locations of the part, where which we have to avoid. Building the inserts opposite to that, which can absorb those. There is a air vent which allows the air to flow there, and the traps would be avoided. And this is the meshing, where we have two types of meshing. One is surface mesh and the solid mesh, where you have the 15 layers of meshing happens here. And the triangular prism and tetrahedral meshing, it is based on the thickness of the part. We can select what type of meshing we can go. And also, in any FEA, the density of the meshing, more the density of meshing is more the accuracy of results. So that is how we select the meshing. And you can see an example of solid meshing, where we can localize if there are some critical areas in our part which has to be more accurate, and which is very critical. We can localize the meshing, and we can make the meshing denser over that area, and non-critical areas we can keep the less denser meshing to make up the time, and we can optimize the time of meshing and the analysis. So this is about Plastics Part Designer, which gives you the options of predicting the defects in the early stages at the part level, where you can make a design suited for injection molding. You can avoid common problems, and you can improve part quality. Let us go on to see the mold designer aspect, where mold designer, it's not just sufficient for a mold designer to look at how the part fills, whether there is a weld line or so on, but there are so many other aspects which has to be considered for a mold designer, where the runner balancing and runners, layouts, and the family molds. If there are several parts to be molded in one single mold, there are different cavities with different volumes and different surface areas, where you have to adjust the runner so as to make sure that all the parts with different volumes would fill at the equal time, at the same time. So for that, the runner balancing is very necessary. So we are going to see what all we can do in filling and packing process. Here I would like to bring in one more point, where when I'm a part designer, I'm using the SolidWorks plastics simulation as a part designer. I can have only the filling process. I can analyze the filling process, where you can detect the defects only at the part level, where in the filling process, what happens to the filling, and or during the filling, what could go wrong, and how we can correct those things. But in the mold designer aspect, it is not only filling but also packing, and also cooling and warping, which we are going to see in the next slides. Here in the mold designer aspect, what all we can have as options in SolidWorks Plastics is runner design, symmetrical layouts, where I have to have the symmetry of filling the multiple cavities, and the balancing of runner as described for different volumes and different parts. Filling time has to be uniform, and the venting analysis to how to make the vent so that I avoid gas traps or air traps and so on. Multi-shots and co-injection, where I have multi-shots as well as co-injection of different materials. For example, if you take a toothbrush, you will be having in one set of injection, I'll be injecting a different material which forms the body of that, and another shot of injection which is a different material which fills the handle part of it. So these kind of co-injections, and valve gates and hot runners, where in some situations, in some parts, we have to have the valve gate so as to maintain the flow accordingly. As such, one valve gate starts filling, and at certain point of time, other valve has to open, other gate has to open to maintain the uniform filling. And the gas assisted injection molding, and the insert molding are very common in electrical and electronic appliances, where I have the metal insert which is of a different characteristics altogether. Mechanical properties, chemical properties, everything change, and the temperature also differs. So to maintain the temperature equally and uniformly throughout, we have to have the options to fill with the temperature of the metal. We have to maintain the temperature of the metal so as to it should not distort, and also the plastics material which is going to fill along with the inserts. And the jetting which is flow of injection mold just like a jet, and it forms a different surface on the molding, and the pipe engines as well. So these are the things comes with the filling and packing process, which is for the mold designer to be very essential. So some of examples here where we have multiple gates, which gives us the flow and fill time. And this gives me the filling contribution of each gates. How is that uniform, or we have to do the adjustments, we can see. And this is for the multiple cavity mold layout, the runner system. All these things can be easily built inside SolidWorks Plastics and can be expedited. Family mold runner balancing, where the volumes of the different parts are different. Here it is showing the unbalanced, and in the next slide it is going to show me the balanced, so that we are ensuring the uniform filling time for both the both the cavities with different volumes and different surface areas. And also I can see the volumetric shrinkage at the end of the fill, and it is going to help me what to do, whether to maintain the shrinkage, whether to alter the shrinkage of the part, or to build some jigs and fixtures, some fixtures later molding to constrain the expansion or contraction of the plastics part. And the sink marks, you can see the sink marks, where if on the other side there are dense inserts, the thick inserts, which help, which gives me the sink marks, and how to avoid that, whether to decrease the size of the the inserts in the bottom side, or how we are going to do that. We can, as a mold designer, I will have different iterations to avoid these sink marks. And the cooling time, we can also see the cooling time, how much time it will take as for the cooling. And at this point, I would like to bring one more point, where Cooling time, if we have the cooling layouts already designed inside SolidWorks Plastics and we have done the cooling analysis, it gives me the accurate cooling results. Otherwise it takes it on its own. The software takes some parameters, assuming that the adequate cooling is already given, and it gives you the results. So there is a difference here. It is just for our understanding, but if we want to have the accurate cooling analysis, we have to build the cooling channels across, and we have to see. We are going to see how the cooling channels has to be built. And the node temperature plot here, you can see a lot of results. You can see the inlet flow rate, maximum inlet pressure, and the clamping force in other directions, X, Y, and Z directions. Node temperature at every nodes. I just probe any of this area and I can see the temperature and the other results, the pressure and other things here. Insert wood molding, that is toothbrush, was an example which was taken with different materials. And also I can see the interface temperature, very much important, very much critical here to see the interface temperature between the two different materials for one single part molding, where it is going to affect the quality of the part very much. So it is very important to have the control on this interface temperature. Electrical connector, insert over molding. The inserts are already there inside the mold, and the cover the extra outside package is being filled here. And interface temperature of both the plastics material and the area where the metal and the plastics are in contact. Co-injection in different planes, Y plane and Z plane, and you can see the interface ratio and the fraction at the end of film, skin and material fraction. Fiber analysis, where you can see the direction of the fiber, so that it is whether it is uniform or it is distorted, and so on. Gas assisted injection molding, where you can see the flow versus skin material fraction at the end of the fill. Valve gates, example of valve gates, where first valve is opened and after a certain point of time the second valve is going to open. Till that material will stay in the runner. So this is about mold designer, where improved and optimized mold design, where you can avoid expensive rework of mold, and you can also improve the mold quality. So let us see what is there in the cooling and warp. Cooling and warpage analysis is very much essential for any plastics part, where if there is no adequate cooling, there will be a lot of defects in the part. So to analyze, and the warpage, of course, the warpage is the distortion of the material due to the temperature and other properties, the material properties. It may go out of the dimensions, so which is code of the required dimensions, which we have to correct it by adjusting the process parameters, or by building a fixture and putting the part into the fixture soon after the ejection from the mold. So design cooling system for a more accurate result, where you can have the cooling time analysis, bafflers and bubbles. You can see the layouts, the different cooling layouts given inside this example, the different channels, and the adequate cooling for mold inserts and conforming channels, where the inlet and outlets are specified, how the coolant flows inside, and where it is going to touch the peak temperature, and what is the level of cooling to be given to make sure that the adequate cooling is given inside the mold, and calculates the effects of the mold residual stress and after injection. that is watt page. Uniform mold temperature or accurate cooling system. We can see the graphs here and the images here where it gives me the uniform temperature at the end of cooling with different parameters like uniform mold temperature and adequate mold temperature, and then material above 90 degrees Celsius. You can see the temperature degrees specified in the graphs with colors, different colors. Red is always at the higher end and the blue is always at the lower end. Part warpage, at what is the distortion of the part, what is the warpage occurred in the uniform mold temperature and in the accurate mold temperature where the accurate cooling is given. So that was about cooling and warp. So how these are staged or how this has been packaged for any usage is what we are going to see in the next slide. So before that, we will summarize using SolidWorks Plastics, how it is helpful. As we kept telling, that is predict and avoid injection molding defects at the early stage and eliminate costly mold rework, improve part quality and decrease time to market. And we can also see a customer statement where a customer was having this challenge of iterations, minimized iterations and eliminated mold related production issues, improved lens optics and product aesthetics due to the fiber analysis and bifringence analysis. Eco is one of the major automotive industry, and this is how the packaging is done in SolidWorks Plastics. Standard comes with filling, where you can see the time and flow front, weld lines, multiple gates, short shots, air traps, sink marks. These are the things we can analyze using Plastics Standard, SolidWorks Plastics Standard, which is helping me in only the filling analysis, where if I am a product designer and I just want to ensure that it is only required for me to see the manufacturability of the part and to see the filling process, to analyze the filling process and make sure the filling is proper. Plastic Standard would suffice the needs. But if I am a mold designer, where I have to look at the shrinkage, multiple cavity molds, runner balancing, multi-shot and co-injection, inserts and overmolding, fiber analysis, gas injection, bifringence, runner design, valve kits, all these things comes in Plastics Professional, where we have the filling as well as packing analysis. And the Plastics premium is the package of everything. It comes with along with Plastics Standard, Plastics Professional. Plastics Professional comes with Plastics Standard. So Plastics Premium with all these capabilities, filling plus packing plus cooling plus warp. I have design and simulation of cooling lines, cooling channels, mold inserts, sink mark profiles, cooling time, displacement due to residual stress, that is nothing but warpage. So all these things comes in Plastics Premium. So any designer, anyone who is into both plastics part and mold design, as we understand, the cooling and warpage analysis is quintessential in any mold industry. Plastics Premium would suffice the needs of every plastics manufacturing related issues. So let us get into the product and we'll see a glimpse of how the plastics can be worked out. So here is a flow analysis, what we have already done. You can see something called as flow analysis here. It's very simple to work. I just click on the new study here, and what I just do is I just add the boundary conditions. I select the injection location here, and I spot the injection location. I just select the injection location as required, and I say OK. Now here it is already selected, and once that is done, I can just right click here and I can say create mesh. You have mesh types, different types of meshes: tetrahedral hybrid mesh and hexahedral mesh, and also automatic mesh. We can go to option of automatic mesh if I don't have any local areas where I have to be critically analyzed. I just go with automatic mesh, where it takes very minimum time to give me the glimpse of analysis of, may not be so accurate, depending on the requirement, but hexahedral and tetrahedral hybrid meshes gives me the accurate meshing and also accurate analysis results because of the local area meshing, different local area meshings. And then once the meshing is done, I just select the material. Here I have two types of materials. That is, one is polymer material. I just click the open database, and I can see the default database with all the families, plastics database families. I can see any material and every material, and inside every material I have the different combinations also from Dow Chemical and Anychem, who are the suppliers of this material. And I select PPE plus PA, where you can see all the material providers list with the commercial name of those, Noryl, Ultralyl, and so on. So I just click on PPS and I can see different host of suppliers here with their commercial names. Now, if this is not what I'm looking for, I just can, if I know who is my supplier and what is the commercial name of that, I just go and sort by company, and I can choose whatever I want. Now you can see everyone here, right from the 3M, Applied Chemical, Applied Signal, Bayer, Dove, DuPont, everyone in this list. And I can just go and click which is who is my supplier is. For example, I say BASF. I can see the commercial name of those with the codes, so I can select whichever the material I want. If I don't have that material listed out here, even in the family or by the company, and I have a different set of material which is just in a case, I just go to the user defined database, and I can just right click and create a new material, add material, and I can give my name, and in that I can say edit, and I can have all the properties here. I can add the properties, specific heat and other things, and I can create my own material. Here I can change the values. So here I can change the material, or what else I can do is I can select add a product, and I can set all the constant temperature, PVT, everything here, and I can select my product. Or what else I can do is I can copy and paste. I can also import plastic material. If you have a file, materiality file of your supplier, I just select the file, and I can select some file given in terms of these are the extensions .bin, .xml, .xls. Any of these I can select, and I can load the material very easily, and it will be stored here, so that I can select this material. Once the material of polymer is done, if I'm analyzing all the 4 properties, that is filling, packing, cool, and bar, I just open the database and I can select the steel material also. Here also I have default database as well as user defined database, where I can select my required material with all the properties like thermal conductivity, density, and mold material parameters and other things, and I can select. Now in the process parameters, what I have is the fill settings. Now based on the material, it is already taken some values. Now if I have to change that, I can change it. And in the advanced, I have this flow back switch point percentage, and then I have the co-injection parameters. If I have different material melt temperature, what is the second material melt temperature I can have? And in the venting analysis, cavity initial air pressure, air temperature, all these things I can specify. So I can specify each and every parameters inside the fill settings. And in the pack settings, I have the pressure holding time. It is already taken accordingly, but automatically. But if I don't want automatic, I can just click on this and I can change it. And the pure cooling time, residual stress calculation, everything. And in the warp settings, I have this ambient temperature, where it is taken as 30 degree. Now if I have to change it, I can change it by scrolling this, or I can just go with automatic. So these are the settings I need to I need to fill, and now it is run. I just right click here and I say run. Now once I run, flow, I can have the combinations of run, flow only pack, flow plus pack, pack plus swap, flow plus pack plus swap, and so on. Cooling is available only when there is a cooling channel built in this. Now we can see the flow results. For example, read flow. So now I can see all the results here. Now fill time, what is the fill time, and what is the pressure at the end of the fill, temperature at the end of the fill, and I can also see the weld lines. It gives me the weld lines. See, wherever there is a chance of flow transmit, there are weld lines visible here. And also I can see the air traps. Again, the same here, the air traps are, which helps me in analyzing where I need to provide the inserts for air vents in the opposite direction. So all these, gate filling contribution, if I have different gates and sink marks, there are sink marks here. So these are the things I can see here: ease of fill, whether it is easy to fill this, and so on. And also I can see fill time animated. Now once I have done with all my results, I can also have this report options where I can see the XY plot. And I can also have the advisor. Result advisor gives me the some kind of material which helps me in analyzing the analysis of this. The part can be successfully filled with an injection pressure of so and so, less than 66%, and you will see all these notes given according to the analysis what we have done. This is the advisor. And once all these things are done, what I do is I just go to summary and report, and I say generate report. Once I say generate report, it gives me the report here. I just say OK to this summary, and I give the title and everything, date, everything, and introduction about the analysis, and the special notes if I have to mention any critical areas or some critical observations. And in the generate image file, I'll select all so that it creates the this thing with the GIF and AVI. Your results. Here you can see clippings. I want a clipping of this, and then the template, I can use the classic template or light template, or I can make my own template of my organization with my logos and hidden tiles of my notes of my organization, and I can say okay, so that it gives me the report in terms of PowerPoint presentation as well as Word file, which can be used for sharing the results with the end user or the customer or whatsoever. So the creation of the report is also very easy, and it's very intuitive, and using the SolidWorks Plastics is also very easy, where it is almost self it's like a wizard type, where it instructs you what to do next and in each and every stages, and we can use this. So this is the complete summary of plastics part design. Meanwhile, the results is getting populated. Let us have a poll where I just want to know from you. Okay, I think I have got the results now, and I'm closing this poll in a few seconds. I can see only 51% voted. That's fine. Yeah, now I'll give it a few more seconds because the poll is collecting the responses. Okay, I'll close this, and I'll have one more poll, one more poll question where you just have two answers which you can choose. I'm just launching that poll, and I expect answers from you for this as well. All right, so I'm just closing this poll, and thank you very much for the response. Now let's get back to the screen where I can see the results already populated, and a report is already created. Let us see that. I'm just saving that particular result file onto the desktop. Now let me open that file. My report looks like this in the PPT. I can see the report generated with the title and the content introduction, and the title, date, department, institute, author, introduction, and everything, and the material information here, and the information of process conditions like flow and pack, what is the filling time, what is the mean material temperature, and so on, and the cool process condition, warp condition, flow results, pack results. We did not do this analysis on this. So if there are any special note, and the figures for polymer viscosity graph and volume graph, heat graph, everything, and results, and filling animation as well. You can see the filling animation here. Temperature and bulk temperature, flow front temperature, growth, volumetric shrinkage, all results can be captured, just by click of a button inside the results folder, and the results can be directly shared with the end users, whoever the stakeholders are. So that brings to an end of this presentation, where we try to show you some glimpse of what SolidWorks Plastics are. Any questions, you can email techsupport@beacon-india.com. Thank you very much.